Hello everyone, I'm Jacob Kauf and I'm the nerd on the street, and today we're installing Arch Linux. Okay everybody, we've got a simpler video today. I work with a variety of different Linux distributions throughout everything that I do. I use Debian, I use Ubuntu, I use Ubuntu-based distributions, I use Fedora and CentOS on some machines. It really depends on exactly what a machine is for, which distribution I end up using on it. But for all of my personal computers, my desktops and laptops that I'm actually sitting down at and using on a day-to-day basis, I pretty much always go with Arch Linux. Now, Arch Linux is kind of a meme in some parts of the Linux community. People make jokes about how the people who use Arch Linux think that they're these elite Linux users, that they're not always. But behind all of the jokes, Arch Linux really is a solid distribution. It's got a package manager that I find very robust and easy to use. It's got repositories with a very dense collection of software, and then it's got the AUR, which lets you build software that's not in the main repositories. It's pretty much got everything that I look for in a distribution. Now, Arch Linux is a rolling release distro, which means that it gets updates over time. Unlike a fixed release distribution such as Ubuntu, which makes a major release every 6 months and every single package on your system gets upgraded at that 6-month point when you upgrade your Ubuntu version. Arch Linux doesn't have releases, it's just a continual system where you install updates when it's convenient for you to do that, if that's every week or if that's every month or if that's more often or less often. Whenever you want to install updates, you install them, and when you install updates, all the software on your system gets updated to basically the latest version available. Arch Linux does do some testing before certain packages move from their testing repo to the main repo, but for the most part, if a project, a program out there, publishes a new version, if that's a feature release, then Ubuntu is not going to include that new version until their next major 6-month release, whereas Arch Linux is going to include it probably within a matter of days. Now, if you talk to Linux users about rolling release distributions and how stable they are, you'll probably hear differing opinions. Personally, I find rolling release distributions to be more suitable for personal machines. I find them to be more stable on personal machines. With a fixed release distribution, you're upgrading thousands of packages every 6 months, so when you make that upgrade, there's a pretty high chance that something is going to break or need your attention after all of those packages are all upgraded at the same time. With a rolling release distribution, since things are upgraded just here and there as the updates actually come out, you don't have that dam breaking open of just all these updates coming in at the same time. As long as you keep your rolling release distribution relatively up to date, you might spring a leak here or there, something might require your attention at any moment basically, which is why some people don't like rolling release distros. But chances are it's only going to be 1 or 2 packages that have changed and 1 or 2 things that you need to actually look at, as opposed to the entire system changing drastically like you get with a fixed release distro. And even on top of that, I personally don't find that rolling release distros have all that many small breaks either, but that's just addressing a common concern with rolling release distributions. Well, you know, Jacob, when I come home after a long day and I just want to use my PC for gaming or watching YouTube videos or whatever, I don't want to have to worry about things breaking. And that's a valid concern, and it's a concern of mine, and that's why, number one, I generally don't update my system when I'm about to use it for something. If the system is working and I'm about to do a live stream, or, you know, if I come home after work, I only have a couple hours to work on a video or something, that's not the time to install updates. You know, I install updates usually on the weekends when I have more time to fix things if they break. And then the other aspect of it is, if you're a little bit more comfortable with Linux, then you might be more comfortable with a rolling release distribution, because honestly, if something breaks on my system, I'm fairly confident in my ability to get it back up and running pretty quickly. So that's just a little bit of background about why I like Arch Linux. It is straightforward for me personally. It gets updates to my programs very quickly. I don't like waiting for a big feature release. You know, if it's been released by the application developers, if there's a new Kdenlive version out, I want those improvements now. You know, I don't want to wait until the next 6-month cycle ticks over. And one last thing that I really like about Arch Linux is that it's pretty desktop environment agnostic. You can install a number of different desktop environments on it: GNOME, KDE Plasma, XFCE, LXQt, Qt, basically any desktop environment. I just named some larger ones, but any desktop environment that exists for Linux, somebody's probably packaging it for Arch. And unlike something like Ubuntu, where Ubuntu is a GNOME distribution, they ship GNOME, so they're checking for GNOME bugs. If you've got a bug in KDE, the Ubuntu folks won't help you. The Kubuntu folks might, but they're kind of dependent on Ubuntu as an underlying system, and it creates more layers between you and the software that you're using. Whereas Arch, the people making the distribution, they don't care what desktop environment you're using, and honestly, they don't even mind not having as many users as some of the larger distros. They're just making a really robust bedrock for you to construct and maintain your own ideal system on top of. So with all of those really nice things about Arch Linux said, I've tried showing how to install Arch Linux a couple of times in the past. I've done videos on it before, but it was pretty long ago. It was a few years ago, the last time I attempted it. The last time I had a successful Arch Linux installation on video was probably around 5 years ago, and obviously the quality of my content was a lot lower back then. I was pointing a camera at a laptop screen back then. I didn't have a capture card or, a nice microphone or any of the things I have today. So I wanted to do Arch Linux justice, and that way when somebody asks me in a comment of a video, one of the most common comments that I get is, oh, what distribution are you using? What version of Linux is that? And I always tell people I'm using Arch Linux with KDE Plasma because that's what is on my daily driver. This way, if somebody wants to try out Arch, if you've heard good things about it from people like me, but you've never installed it before, everything that I'm about to show you is detailed in the installation guide on the Arch Wiki. Everything I'm about to show you, every single command is in the Arch Wiki somewhere, and it's fairly easy for me to skim through that installation guide and pick out exactly what I need to do. But there's an interesting phenomenon I've witnessed helping other people install Arch Linux over the phone and things like that, where people actually, they get overwhelmed by all the information. They think that every single command is something they need to run. They don't actually read the English text that's explaining what's going on, and then they get confused and they mess things up, which is kind of their fault for not reading. But if you're somebody who finds it easier to listen to somebody talk than to read, maybe this video will be helpful for you. So that's what we're doing today. We're going to install Arch Linux. I'm going to show you how to install it with KDE Plasma. It's extremely easy to install GNOME or anything else. Once again, if you want a different system, you can check the Arch Wiki out for whatever particulars you want, but I'm showing you the basic setup with Plasma since, once again, that's what I use and that's what people tend to ask me about. The one step I'm not going to show you today is how to make the live disk for installing Arch Linux. You are going to need a flash drive with Arch Linux on it. You're going to need to download the .iso file from Arch Linux's website and flash it onto the flash drive using a program like Etcher. If you've never done that before, check out my video on how to install Ubuntu 20.04 because I showed that process at the beginning of that video. It's the exact same process for the Arch ISO. You're just using the Arch ISO instead of the Ubuntu ISO. So download the Arch ISO. It's very small since it only contains a minimal set of packages. Flash it onto a flash drive, plug it in, and then we're going to cut to the desktop, and I'll show you how to do the rest of this now. Alright guys, so here we are. Like I said, I'm using a capture card, so you're actually going to see the boot menu of the computer that I'm using right now. I'm using a Thelio system, so we've got a System76 splash screen. I'm hitting F12 right now for the boot menu. Your system might have you hit a different function key. Take a look at the text at the bottom of your BIOS splash screen or UEFI splash screen to see which key you actually need to hit. As you can see, I've got an option right here for my flash drive, so I'm going to select that, and here we have our grub menu for Arch Linux. Now at this point, I'm going to perform a step that's only necessary on NVIDIA graphics systems. So if you've got a system with Intel graphics or with AMD graphics, you can just hit enter to boot. Since I have an NVIDIA graphics card in the system right now, I'm going to hit E for edit. That's going to bring up the command line options at the bottom of the screen here that we're actually using to boot the system. I'm going to hit end to move to the end of that line, and I'm going to type in nouveau, N-O-U-V-E-A-U .mode set equals 0. This is going to turn off the mode setting features of the Nouveau driver because Nouveau, or as I like to call it, NoView, the reverse engineered open source driver for NVIDIA cards, it is a marvel of engineering, but it does not always work the best. So to ensure that we don't have any freezing or anything like that, we're going to make sure to enter that in. I'll hit enter and we will go ahead and boot our live system. And it's just going to take a few seconds to boot here. We saw welcome to Arch Linux a little bit higher up. As you can see, we do have systemd. One of the main criticisms of Arch Linux is how much it depends on systemd. It's not really made to have an interchangeable init system. Personally, I'm okay with systemd. I'm not a fan of everything about it, but I know how to use it. So here we are, we're finished booting, and you can see we just have a command line. There is no graphical installer for Arch Linux. Personally, I don't have a problem with that because I'm able to go through this manually, and you'll be able to do it too after this video. Now, the first thing you want to do is connect to the internet. If you have Ethernet plugged in, DHCP will work, so this will probably happen automatically, and I can ping archlinux.org just to check that I am connected, and yes, I'm connected to the internet. That's important because we're going to be downloading all the packages we're about to install, unlike other distros like Ubuntu that actually include the full operating system image on your flash drive, on your ISO file. The Arch Linux ISO is meant to be used with an internet connection, and you're going to download the latest versions of all the packages as you're installing them. Now, I have Ethernet, so that's pretty easy, but what if you don't? What if you have Wi-Fi? Well, here's how we can connect to Wi-Fi. We're going to use IWCTL. That's the current tool that is included on the Arch Linux ISO. That's going to bring us into a different prompt. This is IWD. So in here, we're going to type in device list, and that's going to list out our wireless cards in the system. You can see I've got one, it's called WLAN1. So we're going to type in station WLAN1 scan, and that's going to tell the system to have WLAN1 start scanning for available networks that it can connect to. We're going to type in station WLAN1 get networks, and that's going to list the networks that it's seeing in its scan. You can see NOTS-wireless in there and also NOTS-AUX. Those are my two networks that I'm running here. So I'm going to connect to NOTS wireless. To do that, I'm going to run station WLAN1 connect NOTS wireless. If your wireless network is protected with a passphrase, which it should be, you will be prompted for that. And I'll go ahead and type in my passphrase. And that's all that you need to do. We can type exit to get out of IWD. And at this point, once again, you can ping archlinux.org, or you can run something like IP address to check that you have an IP address on your wireless link. Once you're connected to the internet, we want to synchronize our system clock. That's going to make it easier to download things and avoid potential problems in a few minutes. So we'll run timedate.ctl set ntp true. NTP is the network time protocol, so we're just turning it on. At this point, we also want to verify if we're booted in UEFI or legacy BIOS mode. Now, if your system supports UEFI mode, I would highly recommend that you install in UEFI mode. I'm going to show you how to do it right now. I avoided UEFI for years because I didn't really understand it as well as I understood a legacy BIOS system. Now that I do understand it, I prefer it. It makes things easier with regards to firmware updates and even just managing your bootloader. So to check if you're booted into UEFI or legacy BIOS mode, we're going to run ls-l on sys firmware EFI vars. Now what this is going to do is list out the contents of this directory. If you're booted in BIOS mode, sys firmware EFI actually won't exist. So if you see a no such file or directory error, that just means that you're booted in legacy BIOS mode. If you see a listing of files like I see right here, you're booted in UEFI mode. So we know that we're in UEFI mode. Next, we need to partition our operating system drive. I'm going to run fdisk-l to list out the drives in this system. You can see I've got dev NVMe 0in1 at the top there. It's a 230 gigabyte Samsung drive, or 250 gigabyte on the label. It currently has 2 partitions on it from when I was practicing this before I started recording, but that's the drive we want to use, so we are going to wipe it, repartition it, and then we'll install onto it. So to begin working with that disk, we're going to run gdisk dev NVMe 0in1. I have made a video about working with fdisk and gdisk for partitioning on the command line, so if you want a little bit more information about that, go check that video out. Once we're in gdisk, the first thing we're going to run is O. That is going to create a new GUID partition table. As you can see, doing that is going to delete all partitions, so we will confirm and enter. Next, we are going to type in to make a new partition. We use the default partition number and the default first sector. Now, the last sector, we're actually going to make our EFI system partition, or our ESP, at the beginning of the drive. With a legacy BIOS system, you have a master boot record, and that is where your bootloader is going to install some of its files so that your system's BIOS knows where to boot to. With a UEFI system, we actually need a partition, and that's why I consider UEFI to be better, because it's a partition that's actually exposed, unlike the MBR that's a lot more behind closed doors. So the EFI system partition, we're going to make it a 512 megabyte partition, so type in a plus 512 capital M, and we'll press enter. And for the hex code for an EFI system partition in gdisk, that is EF00. If you're ever unsure of what the hex code that you need is, you can always type L to list all of them, and it'll also let you search if you do that. But EFI system partition is EF00, so I'll type that in. Next, I'm going to make the root partition that we'll use for everything else. I'll type in, enter, first sector, last sector, so that's going to use the rest of the disk, and I'll use the default hex code because we want to use a Linux file system. We're going to use ext4 for this. Personally, I would not recommend separating your home directory out from your root partition unless you've got a separate physical drive that you want your home directory stored on a separate partition. So in this example, we're going to have one root partition that contains everything except for our EFI files, and those are going to be in the EFI system partition. We're going to write those changes that we just made to disk. Yes. And as you can see, we made our new GUID partition table and we wrote our partitions that we specified. Next, we need to actually format those partitions. So for the ESP, we're going to run makefs.fat dev nvme0n1p1. And then for our root partition, we'll run makefs.ext4 dev nvme0n1p2. As you can see, I'm getting a warning since I already had a file system on that physical area of the disk before. Your warning might look different than this if you had a different type of file system there before. You can just hit Y and press enter to proceed anyway. And at this point, we can actually mount those partitions. So we're going to mount dev nvme0n1p2 first. We need to mount the root partition before we mount anything else. So we're going to mount the root partition of our new system to /mnt. That is a default directory that's created in this live environment for us. Now we also need to mount our ESP so that our bootloader can actually install its EFI files into there. You can pretty much mount the ESP wherever you want to. The Arch Linux Wiki uses /ESP, I believe, as an example. Ubuntu-based distributions typically use /boot/EFI for their ESP. So that's what I'm going to use since I learned UEFI on Ubuntu-based systems. That's just what I'm used to. Now, boot EFI does not exist yet, so we need to make the directory before we can mount a partition there. So I'm going to run makedir-p to also create any parents that don't exist, and then we'll put mnt boot EFI. And then we're going to mount dev nvme0n1p1 to mount boot EFI. So both those partitions are mounted now, and we can interact with them now. At this point, I want to take a look at our mirror list. Like I said, when we install the system in a moment, we're not copying files from the flash drive. We're actually going to be downloading every single package that we're installing from the Arch Linux repositories as we're installing. And when I say we're downloading from the repositories, we're actually going to be downloading from mirrors of the repositories. So if we take a look in etc pacman.d mirror list, this is a file that is going to list out our different mirrors that we can download packages from. Now, recent versions of the Arch Linux installer include a tool called Reflector on the ISO file, and it's pretty cool because as soon as you connect to the internet, Reflector is automatically going to run, and it's going to sort this mirror list for you in order of download speed. So wherever you are in the world, it's going to find out which servers you're getting the best response time from, and it's going to put those at the top, and then the slower mirrors will go down toward the bottom. Now, if for some reason you find one of these mirrors isn't working very well, you can always come in here and comment it out. Older versions of the Arch ISO didn't include reflectors, so you had to actually come in here and usually comment out at least a few mirrors to make sure that you're using one that's geographically close to you. We don't actually need to change anything in here since we've got Reflector, but I just wanted to show you that file. And at this point, we can actually install the system. This is the biggest step, and it's pretty easy to do. A lot of people say that installing Arch Linux is difficult, but here's how easy it is. So we're going to type in pacstrap. And pacstrap is a command that is going to install into a directory. So pacman is the normal pack manager we would use. We're using pacstrap for the initial installation process since we're currently running in a live environment, but we want to install into /mnt. So pacstrap /mnt, and then we can specify a list of groups and packages that we want to install. So that's going to include base. I'm going to include the base devel group. Now, base devel is optional. You don't need to install this. I install it on all my systems for two primary reasons. The first one is that base devel includes everything you need to build packages from the Arch user repository. So the AUR includes a lot of software. If you use a lot of different programs, chances are at least one of them is going to be in the AUR rather than the main Arch Linux repositories. So if you're planning on using the AUR at all, you're going to want to install base devel. The second thing that it includes that I normally end up installing anyway, even if I'm not using the AUR, is sudo. Sudo is required for building AUR packages because the make package script uses it. But if you're planning on using sudo at all in order to execute commands while logged in as your normal user, using root privileges, so doing things like installing updates, you're going to want to install sudo, so base devel will pull that in for you. We're going to install Linux and Linux firmware. If you're wondering why Linux is not part of the base group, it's because you can actually install different types of Linux. If you want the LTS release of Linux, you can use Linux LTS, which is something I do sometimes on my personal desktop because I have found that with third-party kernel modules such as ZFS for Linux, they break a lot less often if you're using Linux LTS because it updates the kernel less often. But for this example system, we'll say we just want the latest kernel, which is perfectly fine for most users. And then Linux firmware is going to include things like wireless card firmware that you might need for your hardware. Now for the GUI, like I said, I'm going to use KDE Plasma, so we're going to install Plasma. That's a group. If you want GNOME instead, the GNOME group is just called GNOME, but we're going to use Plasma. And then we've got SDDM is the display manager that we're going to use. So without a display manager, we would boot into a terminal and we'd have to run a command to actually get into our desktop environment Plasma. Now in this case, there's actually a little bit of a disclaimer because SDDM is actually included within Plasma. We don't technically need to write SDDM here because Plasma depends on the SDDM KCM, KDE control module, and SDDM KCM depends on SDDM. So if we just installed Plasma, it would pull in SDDM as a dependency for us. Personally, I like to also specify SDDM so that it gets installed explicitly, because if in the future some weird dependency thing happens and SDDM was no longer a dependency of Plasma, even if I switch to a different desktop environment, I'm still going to want my display manager to remain the same unless I go and manually change it. So I like to install SDDM explicitly. We're also going to install a few more packages. Now these are packages that you could just wait and install later, and the Arch Wiki shows you installing these later. But personally, I always forget to install them, and then I reboot into my new system and I run into problems because they're missing. So I just make it a habit to install them right up front. The first one is Nano. You've noticed I've been using Nano to get into the configuration files so far. Nano is my command line text editor of choice. If something goes wrong in the installation and I boot into a terminal, I don't want to be stuck with V trying to figure out what's going on. I'd rather have Nano, so I'm going to install that right off the bat to make sure it's there. We're going to install IWD. This is what gives you wireless support. Reason why I like to make sure we install our networking stack: IWD is included on the live disk, as we saw. This is what provides that IWCTL command. Now, Network Manager is going to get installed as a dependency of Plasma, so theoretically we shouldn't need IWD. But let's say something goes wrong with the Network Manager install. So we reboot later, after we're done with the installation, we boot up, and then Network Manager's not working. We need to look up how to fix it, but we don't have internet. If you're on a laptop and you can't plug into Ethernet, you're not going to be able to connect to the internet if you don't install IWD or something like it before you reboot. You would have to reboot into the install media in that case. I've had to do that a number of times in the past, so I always make sure whatever we have that we're depending on to install packages, connecting to wireless, we want to make sure that it's there before we reboot into our new system, just to make our own lives easier. Next up, I'm also going to install man, another one you'd think would be in a pretty basic system, but it is not installed by default. So in case you need to look up any information about a command later, you want to have the manual pages installed. The next one is microcode. So Intel-Ucode is the package name for Intel processors. If you have an AMD processor, then you would install AMD Ucode instead. If you have an Intel processor, that's Intel Ucode. And that's microcode. In layman's terms, the processor manufacturers use that to correct errors and things like that over time, possibly security fixes, so it's generally a good idea to have them installed. We need to make sure we install our bootloader, and just installing the package is not enough. We'll configure it later, but for right now, we do want to make sure the grub package is installed. EFI boot manager is something that grub depends on for installing on an EFI system. And finally, console is one. Console is not included in the Plasma group. They leave it out just in case you like Plasma, but you prefer a different terminal emulator. But later, when we get into our fresh Plasma install, you're going to see it's pretty minimal. The first thing you're going to want to do is install more packages probably. And without a terminal emulator, it's going to be hard to install more packages. You're going to have to Control-Alt-F5 into a virtual terminal, and it works, but it's just not as nice. Since we know that we'll need a terminal emulator later, we'll install it right now. So at this point, I'll hit enter, and as you can see, it lists out a ton of stuff. It's going to download 882 megabytes, and it's going to decompress that into about 3.3 gigabytes worth of packages. You may or may not see a message about selecting which items from a group you want to install. If you do see one, you can just hit enter to select everything within the group. You can always remove things later and it won't affect the other items that were installed as part of the group. And at this point, we just sit back and wait while the entire system is downloaded and installed. All right, and that is all finished. Only took a minute or two. And at this point, we're almost ready to actually start using our new system, at least to configure it from our live environment here. Before we enter into it, though, we need to generate an fstab file. That's our file system tab. It's going to list the partitions that we need mounted when we boot. So to do that, we're going to run gen fstab -U. That's going to use UUIDs in our fstab /mnt is going to be our root. And we're going to put the file in mnt etc fstab. And once that's done, we can actually chroot into the new system. We're going to use arch-chroot, which is going to do some extra stuff to make sure we have proper networking and service management and things like that within the chroot. So if you see this, if you run arch-chroot and you successfully get into a prompt, then you have successfully installed Arch Linux. Now we do need to just configure a few things before it's actually a usable system. We're going to set our time zone first and foremost. So for that, we're going to make a symbolic link, ln-sf, and we're going to link from the time zone that we want to be our default. So that's going to be in user share zone info. Now, if you're not sure what time zone you need, you can hit tab a couple times and see your options listed. For me, I want to be in America as my region, and then I'm going to use, there are a lot of different options here, but I'm going to use the Denver time zone. And I'm going to link that to Etsy local time, and that's going to basically make our local time appear in the Denver time zone. We're going to run hwclock-sys to HC. That is going to synchronize our clock from our system's hardware clock, which is usually running in UTC. But now our system clock in our time zone that we just set should be all synced up and correct. Next, we're going to set up our locale. So for that, we're going to run nano/etc/locale.gen. Now, this file has a list of different locales that you can enable. We're actually going to use one of the examples up here. We're just going to come down to this inus.utf8. You probably want to be using UTF. So we're going to uncomment this, and I'm just going to hit the delete key until that example line is at the beginning of the line here. Now, this exact line is also contained in its proper alphabetical place lower down in this file, but since it's listed up here as an example, this is just a text file. Anything with a hash mark at the beginning is a comment, so it doesn't really matter if you uncomment the example line or if you uncomment the actual line later, because they are identical. After we've done that, we are going to run locale-gen, and that is going to read from the file and generate anything that we uncommented, so you can see that has been generated. Next, we're going to nano into etc locale.conf, and this is where we're going to set, once again, the exact same one that we just set. So lang equals in us.utf-8, and we can stop there. So whatever you uncommented in etc locale.gen, that's probably what you want to type into etc locale.conf as well. And that lang is an environment variable. That way programs that run know what locale they're supposed to use. Next up, a little bit more networking stuff. We need to set the host name. So for that, we'll edit etc hostname. And I'm going to make this machine called Archbox. We'll keep it simple. And then we're going to set that same host name in our etc hosts file. so that when we attempt to connect to Archbox, our networking stack knows that it needs to connect to itself. So 127.0.0.1 is a loopback address, and we're actually going to set that to localhost. When we type in localhost, we want it to resolve to our loopback address. We're going to do the same thing for our IPv6 loopback address, localhost. And then on the third line, we're going to put 127.0.1.1, and this is where we're going to use our host name that we set. So archbox.localdomain and Archbox. If you've actually got a domain that you're putting this on, you can type that in instead of local domain. But this line is saying that either of these two things, Archbox or archbox.localdomain, if somebody types that into a web browser or a command or anything else, it should resolve to 127.0.1.1. So we'll save that etc hosts file. Next, we're going to create an initial RAM disk. We're going to do that with make init cpio-P, and the capital P is going to use any presets that are in our system configuration files. Now, you don't technically need to do this because it was done as part of the installation process. When we install the Linux kernel package, as part of the packstrap command, this was run. I just like to run it one more time just to make sure that we do have an initial RAM disk, because that's one of the two things that you absolutely need to boot a Linux system, the other one being the kernel itself. Next, we're going to set our root password. If we were to reboot right now, we would not be able to log in because no users have any passwords, including the root account, and we can't log in without a password. So we are going to run password, and our password I'm going to set to a very secure password since this is the root user we're talking about. So that's done. At this point, I'm going to install the bootloader grub. Now, we already installed the grub package, but we actually need to run the grub install command to install it to our EFI system partition, our ESP. So we're going to run grub install target equals x8664-EFI -EFI directory equals /boot/EFI. So if you're using something like just /EFI, you might be able to omit this option here, since this utility will look in a couple of default locations. Since boot EFI is not the default location for Arch, we're going to specify it, and then we're going to add bootloader ID equals grub. So if your system's UEFI setup utility has a list of different bootloaders that it can open up for you and start, this would show up as grub in there. Another common one to see is Linux Boot Manager or Windows Boot Manager for Windows systems. So we'll run that, and if we see installation finished, no error reported, then we should be good to go as far as the ESP goes. Now, grub is installed right now. If we rebooted right now, grub would start, but grub would not be able to start our Arch Linux system because even though grub is installed, we haven't configured grub. So to do that, we'll run grub make config-o for output. We're going to output to boot grub.cfg. And so when grub starts, it's going to get loaded from boot EFI, and then once it's running, it's going to look in boot grub.cfg for its actual configuration. So at this point, we would actually be able to boot our system if we rebooted and log in. So that's a milestone right there. We're going to finish it up though so that we can get right into a GUI when we reboot. We need to make our display manager actually start with the system by default. So to do that, we're going to type systemctl enable sddm. Now, if you are using a laptop with NVIDIA and Intel hybrid graphics, so if you've got an NVIDIA GPU and an Intel GPU, there are multiple names for that: NVIDIA Prime, NVIDIA Optimus. If you've got one of those laptops, and that happens to include a lot of mid-range System 76 laptops, then there's an extra step you need to perform for SDDM. You need to nano into user, share, SDDM scripts, X setup, and the step that you need to perform here is going to be different based on your display manager. So if you're installing GNOME with GDM, you still have to do something. It's not this exact thing, but you still do need to make a desktop file and make it run the commands that we're about to type in. SDDM is actually pretty simple. Once again, this is only if you have a laptop that has both Intel and NVIDIA graphics. If it's got switchable graphics, you want to open this file up and type in xr&r -- set provider output source mode setting NVIDIA 0 xr&r -- auto, and that's it. And at this point, we would save this file. Now, I'm not going to save this because I'm actually on a desktop computer and it only has NVIDIA graphics. And if you've got a laptop with anything else, if you've got AMD graphics or Intel graphics, or if you only have NVIDIA, you don't need this step. Once again, that is only for people with switchable graphics laptops. I know that there are people out there who have those, and this is a common thing to get hung up on when you're trying to get Arch working on one of those machines. So I wanted to mention that. Now, doing that actually reminded me that I actually forgot one package earlier when we were running our packstrap command. That's the NVIDIA driver. I didn't install the NVIDIA driver. So when we reboot, we would get that Nouveau driver, which is liable to freeze. So to correct that, just to demonstrate, since we're ch rooted into our installed system here, I can just run pacman-s NVIDIA. And pacman --S, that's just how you install a new package on an Arch Linux system. So you can see that is going to pull in our NVIDIA driver, and I'm going to run that. If you think of anything else you want to install, you can install Firefox, you can install GNOME 2048, you can install anything that you want to while we're in this system here, and then if you install it now up front, you won't have to remember to go and install it later. So the NVIDIA driver's installed now. We're getting really close to the end here. Now, we do want networking to start up automatically when we reboot the system once again. We did install IWD earlier just as a backup plan in case Network Manager doesn't work, but since we're using Network Manager, we are going to run systemctl enable Network Manager. And we can see that is successful. The last thing we need to do before we reboot is actually make ourselves a user account, because everything we've been doing has been run from root. And when we reboot, we're going to see right now an SDDM screen with no users listed, since we can't log into a GUI as root. So to add a user account for ourselves, we will run user add -m. That is going to create our home directory, which you need it to do that to avoid issues with certain programs. We're going to run -G wheel. And that is going to also add this user to the wheel group as an additional group. Since that G is capital, this is not going to take over as our primary group, it's just an additional group we'll be in. And then the username, I'm going to make it Jacob. Now the reason why I'm putting that -G wheel in there is because we're going to use the wheel group for sudoing, which we'll get to in just a moment. First though, I do just want to set the password for the new Jacob account, so I'll go ahead and do that. Okay, my password is set, so I would be able to log in now. And now I do want to add myself to the sudoers group, because everybody knows how annoying it is to try running a sudo command and you get that weird error message that's telling you that it's reporting to somebody, but you're not in the sudoers file, and you try to use sudo and you're thinking, who can it possibly be reporting to, because I'm the owner of this machine. So to make sure that we don't have to deal with that, we're going to nano into our etc sudoers file, and we are going to do a search for wheel. And down here, we've got uncomment to allow all members of group wheel to execute any command with sudo. So we'll uncomment that, we'll save that file, and that is everything we need to do to have a perfectly functional installation of Arch Linux on this system. So to demonstrate, I'm going to exit out of the ch root. I do like to run sync at this point, because depending on your hardware, if the shutdown goes wrong and you have to hold down the power button to actually get it to turn off, I don't want to have to guess, well, was everything that I did written to disk or not, so I just run sync to have a little bit of peace of mind. And then we're going to run sudo systemctl reboot to actually restart this system. And I will show you that it is a perfectly usable system. It looks beautiful with KDE Plasma, just as usable as any GUI distribution, and like if you had installed Kubuntu or KDE Neon or something like that. So here you can see grub works, and automatically after 5 seconds it is going to boot our default image, which is Arch. And we can see our FS tab checking our root partition, and you can see we do have SDDM. So this is our login screen. We've got that showing up properly. Plasma is the only desktop environment that we have installed right now. So I can enter in my password here, and we will log into KDE Plasma. We can see Network Manager is working because we've got our wired connection 2 activated automatically there. And we have a fully functional GUI environment. This is Arch Linux, and after just an hour, just under an hour on the recording right now, including the introduction, we have a functioning GUI here. So Arch Linux is not opposed to a GUI, it's just opposed to a GUI during the installation. If I open up our menu here, we can do just a couple of basic tasks to demonstrate. There's no tricks here. This system really is ready for use now. We can go to our theme. I'm gonna set this to the Breeze Dark theme since I personally think that one looks a little bit nicer on the eyes. And then one notable thing that is missing right now is a web browser. We don't have Firefox or anything installed like that by default, and I'm not going to install Firefox by default because I don't like the direction that Mozilla is going. And it's a very large package if you don't actually use it. So I am going to open up console, the terminal that we luckily remembered to install earlier, and we are going to run sudo pacman-s falcon, which is KDE's web browser. I'm going to run that. We're going to see that sudo is configured properly because it lets us run this command. So that confirms that we set that up and installation is done. I'll X out of our console there, and I'm actually going to add console to our favorites menu. And I'm going to do the same thing with Falcon now that that is installed. Add to favorites. I'll drag these up here. And I can open up Falcon, and now we can actually browse the web and do whatever it is that you were planning on doing with your computer. So, did this take a few minutes more than installing Ubuntu? Yes, I probably could have done it in about half the time if I wasn't explaining what I was doing verbally, but it is still, even for me, a little bit slower than installing Ubuntu. But the upshot is that you've got a very minimal system. You know, like I said, we don't have Firefox, we don't have LibreOffice, or, you know, things that you don't necessarily need on your system are not going to be present by default. And whatever you want to install, you're now free to install as you wish. So I hope this video was helpful to some of you guys out there. Maybe you've been wanting to try Arch Linux for a while, but like I said, maybe the Arch Linux installation guide just kind of overwhelms you. It's got a lot of information. You just need somebody to kind of boil down what actually you need to do, which steps are actually necessary in order to get a functioning system. So hopefully this helped with that. If it did help, feel free to go to nerdclub.nots.co and join the Nerd Club for just $3 a month. I want to give a huge thank you to all of our Nerd Club members, both the ones who have stuck around with us for a while and the ones who have joined recently. Your support is greatly appreciated. I'm working on some bigger projects right now, and it's not always easy to churn out tech videos like this one, but hopefully this had some value at least. And with that, that's everything I had to talk about in this video. So I'm Jacob Kaufman, I'm the Nerd on the Street, and I'll see you guys in the next one. Bye.